Well, it's me again, here with the fourth and final project for this semester. Let's get it started. Here we have everything that you will need in order to do this project. So, to begin, we're going to go ahead and explain what an ultrasonic sensor is and how it works. This right here is our ultrasonic sensor. It's got two big main parts. We have our transmitter right here, which is labeled with a T, and our receiver right here, which is labeled with an R. Using an ultrasonic sensor, we're able to determine the distance of an object away from the sensor using this equation of velocity times time divided by 2. Since we know the velocity of sound is 343 meters per second in air, then we can then determine the distance by using the time that it takes for the sound to go from the transmitter, bounce off the object, and then hit the receiver. The second important component to this project is the RGB LED, and the way it works is instead of being limited to only one color, it can have a range of colors by using different concentrations of the three main colors being red, blue, and green. The way it does it is it has the 3 prongs instead of just the normal 2. This longest prong here is going to be the ground, and then each of the other prongs is going to be the red, blue, and green, which can differ based off of the manufacturer. And now on to the coding portion. Here we have a printout of the code just so I can kind of explain its parts and what they do and how they work. This code can be broken up into 3 main parts. The first one being the setup of the distances. So here we have the minimum distance set to 10, the maximum distance set to 110, and then the 6th distance, which is going to be the max distance minus the minimum distance divided by 6, and the half distance, which is the max distance minus the minimum distance divided by 2. And then we're going to state that the RGB is going to be used for the color, and here we have which pins are going to be connected to what on the breadboard and microcontroller. The second part is going to be our setup. Here we're going to state that the trig pin is going to be the output, the echo pin is going to be the input, and then the outputs for the red, green, blue, and our buzzer. Going back to our sensor, we can see that here we have it labeled. Some of them have it labeled on the back. This one is labeled on the front. We have our power, our trig pin, our echo pin, and our ground pin. The third and final part of our coding is where all the fun begins. Here we are setting up our loop. When taking our distance, we're going to be using a double duration, which is pretty much just a floating point. Basically what we're doing is we're using more memory to get more decimal points. Here at the bottom of the loop, we just have a conversion from the metric system to the imperial system, since most of us are more used to the imperial system and kind of attached to it. Here we are saying if the distance is less than the minimum distance of the 10 centimeters, then the color is just going to be red for the LED. For the second part, we're stating that if the distance is less than the half distance and more than the minimum distance, we're going to use this map function, which is going to take a proportion of the distance, the minimum distance, and the half distance, and then use that same proportion to get a number between 255 and 0 for the red, which is basically the concentration of red that is being emitted. And the same for blue, it will take the proportion from the minimum distance and the half distance, and then use that proportion to go for the concentration of blue. Here we can see that the concentration for red is going down while the concentration for blue is going up, and that is just because we are going towards blue, and the closer we get to blue, the less red there is. And finally here we're saying if the distance is more than the half distance, then we are going to use that same map function to get a proportion of the half distance and maximum distance to get concentrations increasing of green and decreasing. And then if the distance is greater than the max distance, the LED will just... The final part is just what will be printed on the serial monitor. Here on the serial monitor, we can see the distances and the corresponding colors that go with it. And if I put my hand in there, you can see the concentrations of red and blue, as well as hear the very annoying buzzer. And now for our little demonstration. Here we can see the breadboard with the ultrasonic sensor as well as the LED. And it is changing color. It's picking up something, I'm not really sure what, but if I put my hand over here, you can see that it changes color, and as I get closer, the color becomes more red. As I get further, it will become closer to blue until I remove it entirely, and then it switches between blue and green. Using this serial plotter instead of the monitor, we can see this orange line, which would be the distance line, and then there's a red and a blue and a green line, which represent the concentrations of the corresponding colors. Again, I'm going to put my hand here. We can see the blue and red changing. As I get closer, the red increases and the blue decreases until the blue becomes 0 and the red is entirely. And as I get further, the opposite effect happens.